Hello, Algebra 2. How you doing? Thanks for joining me. Hope your day is going fantastic. Let's jump right into it, shall we? We're looking at solving rational inequalities. 7.5 and 7.6, we were solving equations and we were solving for x. There might have been more than one answer for x, but we were solving for x. Now we are solving inequalities. The best way to solve inequalities, in my opinion, is by graphing. And that's exactly what we're going to do for each of these. So I'm going to use my trusty friend Desmos. And as you can see here, it says x over x plus 5 is less than or equal to 0. So I like to think of where is x over x plus 5 less than or equal to 0. So if we jump in to Desmos and we type that function, we're asking ourselves, where is this graph less than 0? Well, I've plotted the graph and I've plotted the line y equals 0. Where is my function less than or equal to 0? Anytime it's above 0, that means it's greater than. Anytime the graph is below, that means it's less than, right? I think that makes pretty crystal clear sense, right? These numbers are bigger than 0, and these numbers are less than 0 as we go into the negatives. So our graph is less than 0 starting from 0 itself, right? And everything to the left as it gets closer and closer to -5. You see that? How it's getting closer and closer to -5? So our answers are not just x equals a number. Our answer is a set of numbers. So where is our graph less than 0? It is less than 0. Let me switch back so I can write it properly for you. It is less than 0 between -5 and 0. It's equal to 0 at 0, so we use a bracket to include. Does that make sense? I can flip back to the graph here. You can see that the graph is greater than 0 over here. It's greater than 0 over here, but it's below 0 starting from here all the way to the left, right, as it gets closer and closer to -5. But there's an asymptote at -5. You see how it's just getting closer and closer? That's because our function is undefined at -5. You see that? Because -5 plus 5 is 0. That's why there is this asymptote in the first place. We've dealt with asymptotes before. You might have been super reliant upon Desmos at the time, but let's keep going. Also, I guess before we continue, before we move on from this problem, we can write it like this, or we can write it like this. -5 is less than x, which is less than or equal to 0. These mean the same thing, right? This says, because again, we're solving for x, but x is not just a number, it's a set. So it can equal 0, or it can be less than 0, right? But it has to be bigger than -5, right? So we're trapping it between, it's trapped between -5 and 0. So these two things mean the same thing. I will give you a fair warning though, this is how it's written on Canvas, okay? But hopefully you realize that those two things mean the same thing. Let's try it again. X minus 3 over x. Let's use our trusty friend Desmos here. So x minus 3 over x. Oops. I need that in the numerator. X minus 3 over x. So we're undefined at 0, by the way, right? I think that's worth noting each time, right, where we are undefined due to the fact we can't divide by 0. So where are we greater than 0 is the question. Here's that 0 line. The graph is above this line starting at 3 and then continuing on, right? So anything bigger than 3 will be above this 0 line. Because remember, we're talking about these x values along the x-axis. When you're at x equals 2, you're below. When you're at x equals 3, you're crisscrossing, and anything beyond 3 means that the graph is above. So x is greater than 3 is part of our solution. Let me go ahead and write that down. X is greater than 3 is a part of our solution. Or, again, the way to write it the other way is that we're starting at 3 and going off to infinity, right? We're starting at 3 and going off to infinity. And then looking at this side, starting at 0, right? We're getting really close, right? But it's just going up, 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 up. So all of this graph, look at it go off forever, right? All of it is greater than 0. So how do we write that? Well, at 0, the function doesn't exist. So anything less than 0 is going to be above this 0 line, right? The blue line represents 0. All of the function is above it. So everything less than 0 is going to be above the graph, or above the blue line. So anything less than 0. Okay, so let me write this properly. X is less than 0 or x is greater than 3, right? That's kind of our final answer. Or with the set notation, you could say negative infinity to 0 unioned with 3 to infinity. Every single problem on Canvas is going to be this way, okay? Like, there's going to be no surprises. It's just 10 problems that are all like this. Let's go back into Desmos. So, oops, I didn't mean to close it. I just wanted to delete it. X plus 4 in our numerator, and x squared minus or plus 2x minus 8. Now, this graph, something worth noting, right, is that if you attempt to factor this, if you attempt to factor the bottom, you would get x plus 4, x minus 2, and these guys cancel out. Interesting, right? Which is why there is only one asymptote, right? At the 2 value, right? Because that's what's left. 2 minus 2 gives us 0. If I go back to this, 2 minus 2 is 0. So I can't plug in 2. Hence the reason for the asymptote. I think that's always important to keep noting, like, okay, there's an asymptote there. Our function also doesn't exist at 4, by the way, even though it canceled out. Desmos isn't showing you that exactly. Desmos isn't as smart as that. But our function technically doesn't exist at 4 either. There's like a little blip in the radar. So, where is this function less than 0? Where is this function less than 0? You can see that the graph is below this blue line for everything on this side, on this left half, right? There's 2 halves of this graph, the right half and the left half. So this left half, all of it is below 0, right? So everything less than 2, case closed. Everything less than 2, all these x values, this entire part of the graph is less than 0. So we simply, all we have to write is x is less than 2. Let me speed things up instead of over-analyzing the graph here. X over x squared minus 81. So something interesting is going to happen here. We're going to have two asymptotes at 9 and at negative 9. How did I know those numbers so quickly, you might be asking? Well, because this factors into x minus 9, x plus 9. So both 9 and negative 9 will make the denominator 0. So, oops, wrong scene. So looking here, where is our graph greater than or equal to 0? Where is our graph greater than or equal to 0? You can see here that it is greater than 0, all of this, right? But then all of a sudden it comes back down below. Where is it crossing at? It's crossing at 0, 0. So it is greater than 0 for this little part right here, right? Let me kind of zoom in on this area, right? From this part to this part. So let's describe that. How is that described? Everything less than 9 all the way up until 0. So we're trapped between negative 9 and 0. That part is above the blue line. So how do we write that? Well, everything between negative 9 and 0. Actually, it can't equal negative 9 though, right? It can't equal negative 9. So, because I literally can't plug that into my function because I'll get a rational value there. So, I can plug that in. And then, does it go back above 0 at some point? Yes, it does over on this half, right? From 9 on out to infinity. So, everything bigger than 9 is also greater than 0. Now, notice it said greater than or equal to 0. Which is why I included the 0. At 0, 0, I like how I said I was going to go quicker on this one, and then this one ended up being a little more going on. At 0, 0, it's equal to 0, right? But then as the graph drops down, it's below. And then on that right half, it's greater than 9. Okay, maybe on E I can be a little quicker. We'll see. Oh wait, there's only 4 examples. Oh wow, there's only 4. For some reason I thought there were 6. So the video is only 12 minutes long. Perfect. If you're still a little puzzled or you're not seeing everything quite right, you can stick around. I didn't even ask a question at any point. So let's have a fun question here. So that way I know that you watched the video. But if you want to see me do one more, let's do one more, right? It hasn't even been 15 minutes. I bet you have the time. If you want to see one more because you feel like you need one more, here we go. Let me just make up some graph, right? Let's say x minus 3 over x squared plus 4x plus 4. Check that out. And we want to know, when is this... that's a weird graph. Let's say plus 6x minus 16. Is that what I want? Yeah. So x plus 6x minus 16 factors into x plus 8, x minus 2, which is why there's an asymptote at negative 8 and why there's an asymptote at 2. So factoring still is important. And, you know, we can go both ways. Where is this graph less than 0? This blue line represents 0, right? The graph is greater than 0 when it's above. The graph is less than 0 when it's below. And we are wondering for what x values, right? Because we're describing the x values. When x is between negative 8 and 2, when x is between negative 8 and 2, our graph is greater than 0. between -8 and 2, our graph is above the blue line. When is the graph less than 0? Well, when x is less than -8, right? As I decrease the x value, right? -10, -12, -14. As I decrease the x value, my function continues to be below the blue line. So for anything less than -8, the function is less than 0. As I increase this, oh wow, I didn't even realize that this went above. So it is greater than 0 between -8 and 2, and then where is that happening? That's happening at 3. So at 3, from 3, everything greater than 3 is also greater than 0. Everything greater than 3 is also greater than 0. But anything between 2 and 3 is going to be less than 0, right? It's about, is it above the blue line? Is it below the blue line? Okay, figure that out. And between what two numbers is that occurring? All right, beautiful length of a video. Thank you for watching. I'll see you in class. Have a good one.